Okay, so this is lesson 2, still under projectile motion, and we'll be looking at the horizontal component and the vertical component of the velocity. So suppose an object is being thrown with an initial velocity v, and it makes an angle of theta with the horizontal. So if this is the initial velocity, we're going to have the horizontal component going this way and the vertical component going this way, or this way. Let's do it this way also. We can also do it this way for the vertical component. And mind you, this vector here and this vector here they are symmetrical. So I can equally call this the vertical component or this the vertical component. And this here is the horizontal component. And don't forget that the horizontal component remains the same at every point on the curve. Remains the same because it's going horizontal, and the acceleration, the force of gravity doesn't act in the horizontal direction, it only acts in the vertical direction. So that's why the vertical component of this velocity will be affected by the force of gravity. So that's why it will always change at every point on the curve. That's for the vertical component. But horizontal component will always remain the same at every point on the curve. So let's see how we can calculate or the shortcut for getting the vertical and horizontal component of this velocity here. So of course we know this is a right angle triangle now, and we can now use our SOHCAHTOA. So using our SOHCAHTOA, so we know that from SOHCAHTOA, the SO, that's sine theta, equals the OH, which is opposite over hypotenuse, and the CA, which is cos theta, will now be adjacent over hypotenuse, and of course the TOA, the T there is tan theta, will now be equal to the opposite over adjacent. So bringing this triangle out, since we now agree that this is the vertical component and this is the horizontal component, remember the vertical component is your v sub y and the horizontal component is your v sub x. So bringing out this triangle, I'll have it this way. And let's start with the vertical component. So I have my v. I'm just replicating this diagram here and want to find our v sub y. This is the vertical component, and we're using v sub y because it blends with the y-axis. So we're just writing v and we'll just put a subscript y there to make it our vertical component. And of course this is our angle theta. So here, since this is the angle we are considering, this is our opposite, and of course this is the longest side of the right angle triangle. This is our hypotenuse. So we have OH, means we're going to use sine because it's OH here and also OH here. So sine the angle will now be, what is the O? The O is the opposite, and that's v sub y, over the hypotenuse is this one, the value here, which is v, and then you cross multiply and make my v sub y the subject of the formula. So my v sub y, put this 1 over 1 and then cross multiply, then v sub y times 1 gives you v sub y equals v times sine theta gives you v sine theta. So this is your shortcut for getting the vertical component of the velocity at any point on the curve. So your v sub y will now be equal to the velocity times sine of the angle that is making with the horizontal. Then let's go for the v sub x. And again, you draw your triangle, bring out the triangle again, this same triangle, right angle triangle, of course, put your v, and now we're looking for the horizontal component, and that is v sub x. It will be here. This is the horizontal component, part of the magnitude of this velocity. So we have at an angle theta. Again, now we have, nothing is here, but we have something here. This is the adjacent, which is A, and this is the hypotenuse, which is H. So we have AH, and of course AH blends with cos theta, AH. So you're going to write cos of the angle equals to, what's the value of the A? The value of the A is v sub x over what's the value of the H? The H is v. So, and of course I'll cross multiply. So v sub x times 1 gives me v sub x equals to v times cos theta gives me v cos theta. So this is the value for, so v sub x has a component of, has the shortcut of v cos theta. So to get the horizontal component of the velocity of that object forming this curve, At any point, you are going to use this shortcut, the velocity times the cos, the angle that the velocity is making with the horizontal. And mind you, don't forget that the horizontal component never changes. It remains the same on every part of the curve. So in the next lesson, we are going to look at the velocities at the maximum height. That will be lesson 3. So see you there.